Hi there guys, welcome to the last video of this exercise. Now here we have this function here for y equals all of this, and here's the quite attractive looking graph. And we just have to show that this point is quite nice. They're just saying here is the answer, can you just show us it? That this point here is 3, 0. So when anything ever crosses the x-axis, you know that the y coordinates are equal to 0. So let's rewrite this whole thing, but let's put the y equal to 0. So 0 is equal to 3 plus 5x plus x squared minus x cubed. Okay, now I think the easiest way of doing this is using your algebraic division. So if x is 3, and we just got to show that 3 is a factor of this and it's equal to 0. So you could do this. So if you know x is 3, and if you imagine when you solve quadratics, you would have had that. So you could see whether x minus 3 is a factor of this polynomial. So you could do some algebraic division, but in fact there's an easier way, because when you learnt this, you learnt about I can't remember what it's called, but I think it's a Factor Theorem or something like that. So x is 3, you can put 3 in here and show that it equals 0. So if we say the function of 3, so let's say this is the function of x, the function of 3 is going to be 3 plus 5 lots of 3 plus 3 squared minus 3 cubed. And if that's equal to 0, we're proving that when x is 3, the y is 0. So 3 is 3 plus 15 plus 9, well, that's 27, take away 27, is equal to 0. Therefore, C is equal to 3, 0. You would have got exactly the same result if you did your algebraic long division, which I know some of you are very fond of. There you go, there's part A done. So B, using calculus, show the coordinates of A and B. So okay, it's going to be quite a lot of work this, because we've got 2 points. We've got to work out which one is the maximum, which one is the minimum. But we know that the derivative, the gradient function, is 0. So that's what we're going to have to do. So let's find dy by dx. It's a nice one. It's got no fractions or anything in it. So if we differentiate this, we're going to have 5 plus 2x minus 3x squared. And we can put that equal to 0 because the gradients at those 2 stationary points are 0. Okay, I don't particularly enjoy factorizing when the x squared term's negative, so you can look at it 2 ways. Put everything on one side, I think that other side, I think that's easier, or you can think of timesing it all by -1. Okay, so we're solving a quadratic, so let's factorize. Of all of these, they've been pretty nice. They've given us prime numbers. So it's going to be 3x and x. And I know if I times that by 1, I get 3x. And then I can take away 5 to get the 2x. And everything works. So we've got here x to be 5/3 and x to be -1. So we know at this point here, that must mean that x is -1. We just haven't got the y. And this point here, we know that must be 5/3. We just haven't got the y yet. So that's what we've got to do. So let's pop it into this function here. So let's start with the ugly one. So when x is 5/3, so y is going to equal 3 plus 5 lots of 5/3 plus 5/3 squared minus 5/3 cubed. So I know some of you are going to grab your calculator straight away. I'll let you do that for now. You could write them all out as fractions, put them all over 27. You'll get this as your answer. So 9 and 13 over 27. Okay, so that's this one. So that's 9 and 13 over 27. let's just put it underneath for now. So when x is -1, we can have exactly the same thing. So y is going to be 3 plus 5 lots of -1 plus -1 squared minus -1 cubed. I'm going to do this without a calculator. So 3 minus 5. -1 squared is 1, so plus 1. -1 cubed is -1, but it's minus -1, so that's plus 1. So -2, -1, 0. Actually, why did I even do that? We're told that in the question. So that's -1, 0. Okay, we're not asked to prove that it's maximum minimum, so there it is, we're done.